quickly. All right, so worksheet 3, number 2, the height of an object that is thrown vertically into the air is given by this position function. What is the velocity? So when I look at example number 2 on worksheet 3, for part A, I can write that S of t S prime of t or V of t is equal to what? How do I figure that out? How do I go from this column to the next one? Derivative. So it's 800 minus 32t. What's the velocity at time t? That's this right here. There's my final answer, highlighted in pink. Now I go to B. At what time does the particle reach its maximum height? As soon as they say height, where do you start? Do you start at position or do you start at velocity? Why is this 32?
Yeah.
Because the derivative, the power, 16 times 32, subtract 1. Did you do the lessons for 1, 2, and 3 yet? That's why. Yeah, because we're doing the application of those derivative rules now. Okay? So for B, at what time does the particle reach its maximum height? So if I come over here and I think about this, all right, this is going to look like something like this. Maximum height is going to be up top here. What do we know about maximum height? What is the slope of the tangent line? 0. That is going to translate into velocity or derivative. So I'm going to take 800 minus 32t and set it equal to 0. That's going to give me t is equal to 25, which is the answer to my problem. When t equals 25. So this is that 25 in the middle right here. Now part C says, and you have this in your notes, part C says, what is the maximum height? So here's part C right here. So part C, they want to know the maximum height. Well, if I have that the time is 25 when it reaches the maximum height, which function talks about height? Position. So I'm going to go back to my position function, and I'm going to find S of 25. That gives me 10,000 feet as my answer. So my answer to the green section is 10,000 feet. Part D, how fast is it moving as it strikes the ground? Right? In my original picture up here, where does the object strike the ground? Doesn't it strike the ground right here? And that is known as what graphical feature? X-intercept. Okay? So here's what we have. Strike the ground means x-intercept. And x-intercept has y equal to 0. So I'm going to take 800t minus 16t squared and set it equal to 0. Fold this out for a second. All right, so notice where I am, A, B, C, D. I'm down here in this blue section. I answered the green. I'm down here. So when I solve this, this is a quadratic. I could take the negative 16t out. I get 50 minus t equals 0. So t equals 0 and t equals 50. So here's 50. Here's 0. That's when it touches the ground. But we have to be careful. Notice I didn't highlight that answer. Did they ask me for time or did they ask me for height? They asked me for height. So if I know the time is 50, how do I get the height? This is what I know is this point right here. 50 is this. Plug it back into the original function. Okay, so my original function I have all the way up here. So I'm going to get s of 50. Hang on one second. For this problem, we are in D, correct? We found the time as 0 and 50. What are we finding in D? I misread that quickly. What does the problem ask us for up here? How fast it's moving. Which function is talking about how fast it's moving? Is it the first one? Position? Is it velocity? Or is it acceleration? How fast it's moving? Velocity. So I'm going to take, and I'm actually going to have to go over here and do s prime of 50. So s prime of 50 is going to be 800 minus 32 times 50, which comes out to 800. And the units are feet per second. Okay. Anytime they ask you questions about acceleration, they will be specific to acceleration. When they say speed or how fast, go with velocity. All right, so let's take a look at the last problem, E. So for E, determine the time required for the object to reach a height of 9,600 feet. Okay, so we're right here in yellow, all the way up at the top. So in part E, determine the time required for it to reach this height. Where do I have a function that relates time and height? The first one, the position function. So all I need to do is take the position function. Let me push this up so you can see it here. I'm going to take the position function, which is 800, minus 16t squared, and set it equal to 9,600 feet. Okay. Now, as a refresher, if we're looking at the graph that we have here, we're saying that this is 9,600 feet here and here. So we are setting the function equal to that to solve. This is a quadratic. It can all go on one side. So 16t squared minus 800t plus 9,600. Take out the 16. T squared minus 50t plus 600. 16 goes away because it's just a plain old number. And at 20 and 30 seconds, that is when the height is 9,600.